Hello friends, welcome to the video lecture series on digital image processing. I am Dr. Dafda, and in this fifth video class of DIP, we will study relationship between pixels, neighborhood, adjacency and distance measures between pixels in DIP or digital image processing. So as usual, starting with the name itself. Why? Because everything is there in the name. What is the meaning of relationship? Relationship means connection between pixels, neighborhood that means nearby, adjacency means connectivity, and distance measures means to measure the distance between pixels in digital image processing. So why do we need to study the relationship between pixels in digital image processing? See, digital image is made up of number of pixels, right? And we will be manipulating these pixels. That means we may be adding some constant to the pixel, we may be subtracting some pixel, we may be compressing the pixels, we may be expanding or increasing the pixels. Okay, and also it is an important concept in digital image processing. Why? Because it is used for establishing boundaries of objects and components of regions in an image, and that is the reason why we study relationship between pixels. Okay, so let us start. So very first we will study basic relationship between pixels or neighborhood, right? So if we consider a digital image, that digital image is consisting of number of pixels. Each of these pixel have a value f of x comma y, where x is row, y is the column. So in this digital image we will be having number of pixels. Now in this digital image, let us call this group of pixels a subset of pixels. So say this is one pixel which we name as P, and one other pixel we will name as Q. Now let us understand four neighborhood pixels for a digital image. So this is represented by N4 of P, and it is also known as four neighbors. Okay, so overall this P of xy will be having four neighborhood pixels. So as this is row, that is x, okay, the value of x will not be changing and the value of y will be changing. So if this is P of xy, okay, then this will be P of x comma y minus 1, because it is the previous value of y, and this will be P of x comma y plus 1, because it is the after value of y. Similarly, if you consider this particular column, then here the value of y will be fixed. So these four are the four neighborhood pixels of P of x comma y. So this is horizontal neighbor and these are two vertical neighbors. So this is known as four neighborhood. So we can write N4 of P. Next is the diagonal neighborhood. So diagonal neighborhood means the diagonal neighbors of the pixel. So what are the diagonal neighbors? These are diagonal neighbors. This one and this one are the diagonal neighbors of P of x comma y. So we can represent the diagonal neighborhood as ND of P. Okay, let's go ahead and understand the 8 neighborhood pixels. So 8 neighborhood pixels is nothing but the combination of 4 neighborhood plus 4 diagonal pixels. So N8 of P is equal to N4 of P plus ND of P, or you can say N4 of P union of ND of P. So that is basic relationship between pixels neighborhood. Now let us go ahead and understand the relationship adjacency between the pixels. What is the meaning of adjacency? Adjacency means connectivity. So two pixels that are neighbors and have the same gray level are called adjacent. See these two pixels, these two are neighbors over here and have the same gray level 1. Therefore these two pixels can be called adjacent. So connectivity between pixels is a fundamental concept that simplifies the definition of numerous digital image concepts such as regions and boundaries. So this connectivity is very important for understanding regions and boundaries, or for finding out regions and boundaries in a image. So there are three types of adjacency: a 4 adjacency, 8 adjacency and mixed adjacency or M adjacency. So 4 adjacency is represented by N4 of P, 8 adjacency is represented by N8 of P, and mixed adjacency is represented by Nm of P. First let us understand 4 adjacency and 8 adjacency. So consider this binary image. For this binary image, we have to consider set V is equal to 1. That means we have to concentrate on the value only of 1 out of zeros and 1. Of course, this binary image will be consisting of different values of zeros and 1, but here we need to consider the set 1. So if we consider this pixel which is having the value 1, it is having 3 adjacent pixels which are having value 1. This is 1, this is 2, and this is 3. So this below pixel can be connected like this in a straight line path, and these two other above pixels can be connected in a diagonal path. So this particular straight line path connection in between this pixel and this pixel is known as 4 adjacency, and connectivity between this pixel and this pixel in the diagonal manner, right, this one and this one in a diagonal manner is known as 8 adjacency or 8-way connection. Okay, now let us consider this grayscale image which is having values from 0 to 255 as we understood in our previous video class, and the subset which we have to consider over here is V is equal to 0 to 10. That means you have to only concentrate on values ranging from 0 to 10. Okay, let us consider this pixel, right? So this pixel having value 6 can be connected to this pixel which is having value 5, because 5 is coming in between 0 to 10. So it will be connected like this in a straight line path. It cannot get connected to this pixel, that is 66, 166, 1919 and 7777, because these values are greater than 10. But it can of course be connected to this pixel diagonally as well as this pixel diagonally. So this particular connection is known as 4 adjacency as it is connected in a straight line path, and this particular connection is known as 8 adjacency as it is connected in a diagonal path, right? Say from this image one other pixel is also present which is having value 0 to 10, that is 8, right? But this 8 pixel cannot be connected to any of the pixel directly or diagonally, right? So this is not connected. Similarly, for this binary image, this particular pixel is not connected to any pixel. Now let us go ahead and understand M adjacency or mixed adjacency. So this mixed adjacency is a modification of 8 adjacency. It is introduced to eliminate the ambiguities that often arise when 8 adjacency is used. For example, consider this particular pixels, and for this particular pixels, say we have a set again V is equal to 1. This pixel can be connected to this pixel diagonally like this using 8 adjacency, right? It can be connected to this pixel using 4-way connectivity. Now this pixel can be connected to this pixel again using 4-way connectivity, and also there is a confusion or ambiguity over here that this pixel can be connected to this pixel using 8 connectivity, right? So you can see here this can be connected to this diagonally as well as it can be connected to this in a straight line path. This pixel can be connected to this in a straight line path, and this can be connected to this as well in a diagonal path. So there is an ambiguity whether to connect this pixel using straight line path from here to here and then to here, or to connect this pixel to this pixel using a diagonal path, right? So mixed adjacency says that if you are able to connect in a straight line path, you should not use diagonal path. Okay, so that is the importance of mixed adjacency. So mixed adjacency removes this ambiguity or confusion, right? It says that if you are able to connect in a straight line path like this, then you should not use the diagonal path. Okay, so these pixels can be connected in this manner, right? This pixel will be connected in a straight line path to this particular pixel. This pixel will be connected to this pixel in a straight line path, and this pixel will be connected to this pixel in a diagonal path, and this pixel will not be connected to this pixel in a diagonal path, right? So this is the correct way of connection, and this is known as mixed adjacency. Now let us go ahead and understand how to calculate the distance measures between pixels, right? So we know that a image can be defined as a two-dimensional function f of xy, where x is the row coordinate and y is the column coordinate, right? And for this particular image having number of pixels, let us consider 3 pixels having values p of xy, q of st and z of uv. So for pixels p, q and z with coordinates xy, st and uv respectively, d is the distance function or metric that is used for measuring the distance between the pixels, right? So let us see different types of distance measures for this particular image and 3 different pixels as mentioned here. So as this is the second pixel of second row and second column, right, the value of p of xy is equal to 2. Similarly, as q of st is the fourth pixel in the fourth row and fourth column, it is having the value 4. So now let us measure the distance between the pixels using different distance functions. First one is Euclidean distance, right? So what is the meaning of Euclidean distance? Euclidean means one that is related to geometry, right? So if there is a path like this between 2 pixels, this is 1 pixel and this is second pixel, then you can connect it using this particular path, okay? And it is given by under root of x minus s plus of y minus t, where x and y are the values of p, the coordinates of p pixel, and s and t are the coordinates of q pixel. So x minus s whole square plus of y minus t whole square raised to 1/2 or under root will give you the Euclidean distance, okay? So let us calculate it. It comes out to be x, that is 2. So this will be minus 2 whole square, that is 4, plus again minus 2 whole square, that is 4, that is 4 plus 4, and raised to of course 1/2 or under root, okay? So 4 plus 4, that is 8, and raised to 1/2, that is under root. That means this will be having value under root 8, right? So Euclidean distance between this pixel, second pixel of second row and second column, is having the Euclidean distance of root 8 in between the fourth pixel of fourth row and fourth column, right? Now let us calculate city block distance, which is denoted by d4 of p comma q. Remember, this city block distance is denoted by d4 of p comma q. Why it is known as city block distance? It is called city block distance because it is calculated as if on each pixel between your 2 coordinates stood a block or house which you have to go around. This means that you can only go along the vertical or horizontal lines between the pixels but not diagonal like the Euclidean distance, right? And it is the same like movement of the rook on a chess field, okay? The elephant or hathi which is there in the chess field, it only moves in a straight line, okay? So this particular straight line path is called a city block distance, right? So for the city block distance, the formula is d4 of pq, which is equal to magnitude of x minus s plus of magnitude of y minus t, okay? So let us calculate it. So as it is magnitude, this will become plus 2 as well as plus 2, so this comes out to be 4, right? So the city block distance between this pixel and this pixel is 4. How? Calculate it like this: 1, 2, 3 and 4, okay? You have to go 4 blocks to come to the destination pixel. See again, you can even come using this path. This is 0, right? So 1, 2, 3 and 4, right? So this is known as city block distance, okay? Getting it, right? So Euclidean distance between this pixel and this pixel was in this path, okay? That came out to be root 8, right? Whereas the city block distance between this path and this path comes out to be 4, right? Now we will understand the representation of a city block distance. So this is an example of how we can represent a city block distance. Okay, these are in different pixels like this. So here you need to remember that the distance between two adjacent pixels will always be equal to 1, right? So if we consider this pixel, the distance of this pixel to this pixel itself is 0, right? If you consider this adjacent pixel, the distance between this pixel and this pixel is 1, right? Again, this pixel will be having value 1 as compared to this pixel will be having 1, and similarly this pixel will be having 1, right? Now we need to find out the value of this pixel, right? So for this we cannot go diagonally, right? We have to go clockwise. So we can go in this direction. So distance between this and this is 1, and this is again 1. That means 1 plus 1, 2. In the same way, if you consider the distance between this pixel and this pixel, that is value 1, and again this pixel and this pixel, that is value 1. That means 1 plus 1, that is equal to 2. Therefore distance between this pixel and this pixel is 2. Now for finding the value of, say, this pixel, right? So from this point to this point it is value 2, and from this point to this point it is value 3, and again from this point to this point it is again having value 1, that is 3 plus 1, which is equal to 4. So this city block distance is represented by d4 of PQ, whereas Euclidean distance was represented by dE of PQ, right? Now see this particular image. For this particular image, the green line is the Euclidean distance because it is going directly diagonally, right? So green line is Euclidean distance, whereas the red line, yellow line and blue line are the city block distance, right? So for this particular figure, this is the Euclidean distance, the green line, and the red line, blue line and the yellow line shows the city block distance, right? Next, let us go ahead and understand the chessboard distance, which is represented by d8 of PQ. So it is given by maximum value of magnitude of x minus s comma y minus t, magnitude of y minus t, right? So why it is known as chessboard distance? It is known as chessboard distance since in the game of chess, the minimum number of moves needed by a king to go from one square on a chessboard to another equals the Chebyshev, or the maximum distance between the centers of the square, and that is the reason why it is known as chessboard distance. So here you have to calculate the maximum distance between the center of the squares. So it is given by maximum of magnitude of x minus s comma magnitude of y minus t. So let us calculate it. So for this particular pixel 2, 2 and 4, 4, this will come out to be maximum value of, so maximum of 2 comma 2 is equal to 2. So hence the chessboard distance between this pixel p of xy and q of st is equal to 2. From here also we can measure distance between this pixel and this pixel is 1, and this pixel and this is again 1, that is distance between this pixel and this pixel is 2, and from this point to this point again it is equal to 2, right? Distance between this and this is 1, and 1 plus 1 is 2, right? So the maximum value between 2 and 2 is 2, and therefore the chessboard distance comes out to be 2, right? Maximum of this 2 and this 2. So of course both are 2s, so maximum value will be 2, right? Now let us understand using this image how we can measure the chessboard distance between two pixels. The chessboard distance is represented by d8 of p and q, right? So value of this pixel is 0, the value of adjacent pixel is 0 plus 1, that is equal to 1. This pixel is again 1, this pixel is again 1, and this pixel is again 1, right? Now we need to calculate the value of this particular pixel, right? So for that, the value between this pixel and this pixel is 1, and value between this pixel and this pixel is again 1, and maximum value of 1 comma 1 is 1, and therefore the value of this pixel is 1. Getting it, right? Consider this pixel. The value between this pixel and this pixel is 0 plus 1, which is equal to 1, and again the value between this pixel and this pixel is again 1. So maximum of 1 and 1 is 1, and therefore the value of this pixel comes out to be 1, right? So that is how you get the values of this pixel and this pixel, right? Now let us find out the value for this pixel, right? Now see, the value between adjacent pixel is 1, as you know, right? So value between this pixel and this pixel is 1, and this second pixel and this pixel is again 1. So that means the value is 2, right? And value between this pixel and this pixel is 1, right? So you have to take the maximum in between these two values, right? So maximum of this is 1 plus 1, that is 2, comma this 2 to this 2 is 1, that is maximum of 2 comma 1, that comes out to be 2, and therefore the value of this pixel will be equal to 2, right? Similarly, let us consider the value for this particular pixel, right? So value between this pixel and this pixel is 1, and this pixel and this pixel is again 1, right? So total value is 2, right? So say max of 2 comma, now the value between this pixel and this pixel is 1, and again this pixel and this pixel is 1, that is 2, right? So value of, or rather max of 2 comma 2, that comes out to be 2, and therefore the value of this pixel will come out to be 2, right? Similarly, say you want to find out the value of this pixel, right? So value between this pixel and this pixel is 2, between these two pixels the value is 2, right? And again between this pixel and this pixel the value is 2, right? So you have to take the maximum value of 2 comma 2, which comes out to be 2, right? So this is how you find out the D8 of P comma Q, or the chessboard distance D8 of PQ. Getting it, right? Okay, so that is how we measure the distance measure between different pixels using Euclidean distance, city block distance, and chessboard distance. I hope it is clear. So that is all for this video class. In the next video class, we will study image sampling and quantization. Thank you very much.